So this is the agenda today. First, we'll introduce this fourth slide, introduce the Bluetooth technology, then introduce the Bluetooth architecture, and Bluetooth stack, and have some introduction. Okay, Bluetooth, as we know, is widely adopted Bluetooth wireless technology on all the mobile devices. So right now, most of the notebook handheld devices support Bluetooth interface. So the reason is that Bluetooth has some key features, robustness, low power consumption, and low cost. And actually, there are two main system phones for the Bluetooth system. One is the basic array, combining this enhanced data rate. Another one is low energy. Low energy addresses the low power consumption. So with the low energy, you can use in a crystal battery when you run in a Bluetooth device over 2 years. So that's another big advantage. For today, because for Bluetooth, there are many systems. So today we only introduce the basic array controller, what we implement, what we intend to be supported. So for the radio frequency is using the 2.4 GHz. It's a licensed band, licensed ISM band. ISM stands for Industrial, Scientific, and Medical Band. It's a reserved radio band across different countries. So using the Bluetooth, you don't need any extra license across different countries. And for the spectrum technology is using the frequency hopping. Using the Bluetooth with hopping the sequence and the time differentiation. So actually there are another spectrum technologies called direct sequence. It's used by other technologies such as Wi-Fi. So for basic array controller, it provides different data rates. First is basic array, you run in 721 kbps per second. And with the enhanced data rate, it runs in 2.1 megabits per second. And for Bluetooth technology, start from revision 3, they introduced another possibility that's using the LAO2 11.5 with it. So if you're familiar, you know the Wi-Fi, so it's the same thing. So you can operate with the Wi-Fi MEC and 5. So it brings more transfer speed up to 54 megabits per second. So that's another big advantage for the Bluetooth. So in here, I will first introduce the 10 in Bluetooth is Piconet. So what is the Piconet? As you know, for the Bluetooth, you need to pairing and searching the device. So for the one who do the searching and to do the pairing is called master. What master did, we provide a reference card for all the slave device in the same Piconet. And what is slave? Slave is the device being connected. So for the slave, you need to synchronize the reference card with the master provider. And in the Piconet, there's only up to 7 active devices. So some people may have questions, what if you have more than 7 devices, how can that work? So in the Bluetooth, actually in the same Piconet, you can have up to 255 PAC device. PAC means it's inactive. So you only access the target device, you can have 8 active access. But at the same time, you can only active 7 devices. So in the Piconet, you can have only one single master because that's the guy who provides the reference card. And you can have up to 7 select devices. So it's called Piconet. Another important term is a scatternet. In this picture, because if you have much more Bluetooth device in the same physical area, so it may be gathered as a different Piconet, or you can have the link between different Piconets. So for the Piconet here, I show you some, show you 3 pictures. The first one, this is a Piconet A, it's a single master with a single slave. For the blue one is a master, blue dot represents the master, and the black dot represents the slave. And net B, there's a single master with 3 slave devices. And for the net 3 is only this net is called Piconet. What is Piconet? You see, for here is one Piconet, here's another Piconet, this third Piconet. So actually there are three Piconets, three masters. So for the first Piconet with the second Piconet is sharing a slave. Another important role, like in the Bluetooth, is the master can act as a slave in another one Piconet. And for Piconet, second Piconet and third Piconet is sharing a slave device. So this means the slave device, you can get involved several different Piconets. Okay, so after the basic technology, we'll introduce the basic architecture. First, I will show you this co-system architecture. What this means, co-system is a traditional Bluetooth, meaning treated as a Bluetooth host or Bluetooth device. So here is a typical co-system architecture block diagram. Here, because we are not going to go through everything in detail, just give you a view because of the upper half is a host, for the lower half is a controller. So for the Bluetooth system, you can incorporate different controllers with the same host. In here, actually there are three types of controllers shown with this. Basic array in the low energy controller, also amp controller. So how about controller interface? In the Bluetooth host, in the stack, we define three interfaces: UART, USB, and SDIO. So which means your USB host can be these three possible interfaces connected to your platform. So here we gonna explain how the data transfer in Bluetooth. So this is an important layer structure for Bluetooth, from bottom to top. This is from physical to software architecture. So first is the physical channel. Physical channel, as in our previous slide, we are saying Bluetooth is using frequency hopping in a type individual duplex way. So for the physical channel, it's charged with frequency hopping and for the packet transfer. So in above the physical channel is the physical links. Physical links is mainly for the link integration. In the previous slide, we explained in the Piconet. Piconet master and the slave, how they do the connection. So they are using the physical link to do the link expression. So there are another upstream layer I use later slide to explain it. So there are logical transfer. Logical transfer, it captures the logical data packet to the packet data. In the future slide, we'll explain what is the data packet format. So here you can just only know actually Bluetooth support the synchronized transfer, also the synchronous transfer. So in the USB term, it's just like the dot transfer or the asynchronous transfer. So for the synchronous for audio and for the synchronous for control or some data integrity guarantee transfer. And above the logical transfer is the logical links layer. It provides some logical control between above the logical transfer. And in the top layer of the data transfer architecture is electric cap. The electric cap will further explain this term. Right now you just don't know it provides some link manager between the master and the slave. And above this electric cap layer, it will be the application layer. Application layer means that right now we know there are Bluetooth headphone, Bluetooth keyboard, mouse. So this is called application. There are special terms in the Bluetooth, we'll explain it also. This is a generic general packet structure transferred in the Bluetooth during delay. So first is access code, then header, then payload. The data payload is encaptured for the higher layer of the data. Here, I'm not going to explain all the detail, but there's important things like the Bluetooth device address. I'm going to explain it, especially highlight, because the Bluetooth device address, just like as you know, like a NIC interface will require a MAC address. It's the same thing like that. And the way you assign the Bluetooth device address is the same way. So which means you can identify the Bluetooth device. It's unique. So you can use this to identify Bluetooth device. Especially one Bluetooth device. Even if it's the same model, but the Bluetooth device address will be different. Okay, here we want to talk about the protocol and the profile. As the previous slide, we explained there are different transfer layers. And here we'll explain the protocol and the profile, what it's for. Protocol is a layer stack from bottom to up, and also from the hardware to software. There are different protocols. For different protocol is a layer stack. This is remember. And there's a spatial term is called profilers in Bluetooth. Profiler, it will intercept for different protocol data. So which means that if you need to support a special profile, you may get involved maybe physical protocol, resident protocol, link management protocol, also higher protocol. So it's a different concept, maybe if you know the USB. Because for USB class is a higher layer, it's not get involved in lower layer. Okay, this is a sample picture of the Bluetooth protocol possible implement in the system. So for the purple one, I'm not sure whether you can recognize it. For the purple one is a core protocol. Core protocol means all the Bluetooth device, including the host, need to support it. Because it's mainly for the link, it's the arrangement, also the transfer, all the things. So first is Bluetooth radio protocol. Radio protocol mainly charge for the frequency hopping, all these things. And baseband provide the physical link and some link restriction. And the link management protocol with a higher management of the link control. And the virtual cap is the virtual link control and the adaptation protocol. We'll further explain this protocol in the future slide. And the SDP is called Service Discovery Protocol. It's an important protocol used by Bluetooth device between to discover what service the target device supports. So for other protocol, this is just a simple picture because they are also IP, TCP/IP, so you can use it to implement the network stack. It's only available for device support. Okay, here I list some Bluetooth profile that you may have used or seen. This is not an exhaustive list. I just only list some. Actually, there are over maybe 30 profiles available right now. So I picked up some like, okay, human interface device profile. It's mainly for human interface device, just like a USB. If you have ever used a USB keyboard mouse, in the USB you define the same class. So in the Bluetooth profile, you also define the same profile for the device. So if the way it operates is totally the same like USB class, it also supports some protocol requests, also the report descriptor, also a boot descriptor. Well, there's another protocol probably you also have a look at the serial port profile. So when you install a Bluetooth host on your target system, you may see like the serial port also get installed. So this is how it is supported. Okay, so this is the last slide I will introduce for the Bluetooth architecture. Here I list the device state that the Bluetooth host or device in MACD. It can be for both Mac and Slack. First, let's take a look at the right picture, this one. I'm not going to all the details, but you just need to remember, first is step by step. Whenever the device joins the Piconet, it's default in a step by step. And another important step is connection, and then pop. So for the master device, we know it will provide a reference clock. Then it will send the parent request to target device. So for here, it's called substep. Actually, there are totally 9 substeps. It's not all listed here. But you can just only remember like for substep what it does for. Just like if you're master, you want to connect a SLAD device. For the master, you will set a page procedure. But for SLAD device, you will launch a page scan procedure to know where any master want to connect. And when device already connected, there are also different states represented here. Active state, cold state, sleep state, and the part state. For the part, we already explained it. For the part, for the unused device, you want to make it idle, you just can put it in the part state. And for the sleep and hold, compared to active state, it will occupy less resource. So for the master, if you have a resource management request, you want to reserve some bandwidth for special device, you may have some device may be moved to hold or sleep. Okay, so here is the most important thing we're going to present today. In the previous slide, I'm trying to use it only few to make you understand what the Bluetooth technology, including Piconet, and how it works. So in the bottom half of this slide will be mainly address UEFI Bluetooth stack, what we implement. Okay, here is the block diagram of the Bluetooth UEFI stack. From bottom to up, top also the same from physical to software. I will go to explain each one of them in the later slides. First is this USB Bluetooth host. This block represents the Bluetooth hardware. So as you know, for the platform you want to access master, you will need a host controller. That's what we already have for the notebook, also the cell phone, your tablet. So actually there's a Bluetooth host integrated with it. So for the Bluetooth host, it can be added to system in some different way. It can be a USB dongle, like if you are using a desktop, you don't have USB Bluetooth host, you can bought a USB dongle from the market and attach your system and you will get a Bluetooth function. So it can be a module. Right now there are many modules like PCI Express projector module available in the market. It's combining the Wi-Fi, also Bluetooth. So if the system has the PCI Express connector, you can use it to get a Bluetooth feature. And it can be solely connected to your platform, or it can be also added to SoC chip. So that's the only way you can have the support for the Bluetooth host. So from here start will be the software layer implementation. So as the target implementation is the USB interface, so first we need to create a USB driver to manage the Bluetooth traffic. So it will redirect the traffic between the Bluetooth and the USB. You will convert the Bluetooth, you will encapsulate the Bluetooth packet to USB packet and send to Bluetooth host to do the Bluetooth transfer. Another layer is called host control interface. We do the same thing as what we represented earlier in the Bluetooth system architecture. So for the host control interface, we provide an extra layer to support different controller. Right now, we only support USB, so actually in the future, we can have the UART, also other interface based on this host control interface to have support. In the higher layer, there's no extra modification required. So for host control interface, we provide several commands corresponding the link control, link policy, resident control, all these things. We provide a protocol to do the transfer. Right now, it's a proprietary protocol because, as you know, right now UEFI over doesn't have the generic Bluetooth definition yet. Okay, the higher layer is Bluetooth bus management. We mentioned what it did. We managed the Bluetooth host controller, Bluetooth device, and we were responding for the connect device. What means we connect? As we know, for the Bluetooth device, if you have a pair with the same host, if you lost the power or maybe you turn it on again, you will get it connected without any extra pairing process. This we call it reconnect. You also provide a pin code check. What is pin code? For some Bluetooth device, if you expect like a security link What it means secure link? Because like a keyboard. As you know, when you pair it with the Bluetooth keyboard, you will request input a certain digital number to get paired with it. You may be able to avoid, it may be paired by another Piconet fast. So this function you can enable or disable, just only if you need it. So the L2CAT particle driver provides the same functionality in the Bluetooth bus line. It's called logical link control and adaptation particle. So what it did, it received the Bluetooth packet from a lower layer, then dispatch the Bluetooth packet, you will read the header, then dispatch the packet to higher layer. Here, there are only two higher layers, SDP and HID profile driver. SDP stands for Service Device Protocol. So for the Service Discovery Protocol, what's the purpose for it? You can use it to get a descriptor from a device. You can get a device name, all the things, attribute, something like that. A lot of features things you can get from it. Just similar to the device descriptor in the USB. So for the security and the pin code function, as we just explained, you can provide protection to the main in the middle tag. So for some Bluetooth device, if you expect security connection, then you can enable the security. Actually, there are more security features provided in Bluetooth spec. Here is just only a pin code implementation, mainly for keyboard. Okay, so another layer is a profile driver layer. Here, there's only one profile getting implemented, is HID profile. HID profile, what it did is manage it, support the HID profile request and the feature. So you will initialize the HID profile, and you will responsible check whether the attached device supports HID profile, then install the higher layer driver, like a keyboard or mouse, if you found a keyboard mouse is connected. So in the Bluetooth keyboard and the mouse driver, what it did is support the device station request. It also passing the input data, also support the heat boot protocol. This is the same like a USB class device. So for the USB heat device, also support the boot protocol and the return protocol. For the boot protocol, it's a single transfer packet. You don't have to pass in the report packet. They are descriptive to know the report data. Okay, so in the UEFI keyboard mouse driver is the main driver which interacts with the UEFI application or something. So for the keyboard, as we know, you need to expose the simple text input protocol and also the simple text input X protocol. So UEFI application can consume this protocol to get a keystroke. This is the way how you get Bluetooth keyboard keystroke. And for mouse will produce the UEFI simple point protocol. This is also a standard protocol defined UEFI spec for pointing device. So for the last block is the Bluetooth setup interface. What's the setup interface for? You can use it to enumerate the Bluetooth device. So in the setup, if you launch the enumeration, you will list all the Bluetooth device scanned in the range. So you can further choose which one device you want to connect or disconnect. And in the setup interface, you can also use the security feature if you want to special the digital number to pair with the Bluetooth keyboard. You can utilize it. And you will also provide some kind of notification if you have any connection failure happen. So this is all the explanation of the block. Okay, so for the Bluetooth, in our presentation, there are mainly these three specs being referenced. Bluetooth core spec, right now its latest version is 4.1. And the Bluetooth protocol architecture, this is all spec, but actually you will give some explanation detail of the boot protocol. If you're interested, you can try to read it. And the human interface device profile stack define all the HID profile command and request how it works. So if you know something regarding the USB HID class, I would encourage you to read it as well. You can understand this faster. Okay, summary. Bluetooth device, Bluetooth technology, there's many advantages. That's why it's widely adopted right now. It's low power consumption, low cost. It's available on all, I think we can say all mobile platforms. And there are many Bluetooth devices already in the market. Not only the human Bluetooth device, many people were using like a headphone. Also the car, right now, they're also using the Bluetooth to do the remote control, like a radio or something. So Bluetooth brings many convenience. And we are thinking that if you have a Bluetooth stack in the UEFI, it will also provide many possibilities in the UEFI. Like for some system, maybe if you want to ship with the Bluetooth keyboard, mouse, if you have this stack, you can download it. And Bluetooth is a wireless technology, which you can do many features, like maybe you can recover system through Bluetooth wirelessly, or using the Bluetooth, implement more profile as another profile, like they are also network profile. So if you have one NIC driver based on the Bluetooth, you can have the same feature like Wi-Fi.
Okay, thank you, Mr. Tony Low from AMI.